So math 2, we're going to do the 7.5 lesson, okay, if the iPad seems to cooperate. So let's look at 7.5 lesson. Okay, so we had this diagram before, but now we know a little bit extra. So what is it that we know that we didn't know before? And so we know that if you have a triangle formed by transversals, that you have proportionality. And so let's see if we can find something like that. Okay, so if I enlarge this a little bit, so if I enlarge it a little bit, there's some things that you recall. So we had that 3, 4, 5 triangle up here, okay? And we have corresponding angles. So 53 degrees, 53 degrees, 53 degrees, 53 degrees. So we have that, okay? And you could also do Pythagorean theorem, right? But let's see if we can use the proportionality and see if we can figure that out. Okay. And so, so for example, if we have a 3, 4 triangle down there, then what must this be? This must be a 9, 12, 15. Okay. And so let's see if we can then figure out the proportionality of the lines over here. Well, let's see, what do we know? So if we look at this 18, we'll say there's an 18 there. And so we've got 18 there. So we have 10 to 18 in that triangle. Okay, so I guess we can figure out. So then we can figure out this one with Pythagorean theorem, can't we? No, we can't, right? Because it's not necessarily a right angle there. But in looking at it, I think something we could figure out. So here's what I'm thinking now is that, so we have in green, so we have 10 is to 18. So this side is to this base. So if these are similar triangles, then 10 plus 15 is to 9 plus 18 plus, we'll call that B. 9 plus 18 plus B. So let's see what we get there. So we have 10 to 18 equals 25. So it should be the same proportion as 27 plus B. And we can figure out then what B should be and see if that makes any sense. So it's the easier proportion is 5 out of 9, right? So then we look at that and say, well, 10 out of 18 is like 5 out of 9. And so if we multiply by 5, then this must be equal to 9 times 5, 45. So this equals 45. So I guess that would be, so B would also be 18. Okay, so B equals 18. Okay, so if B equals 18, let's see what else we can figure out here. So then we can figure out this using Pythagorean theorem, right? And so we have this equals the square root of 12 squared plus 18 squared. So it equals the square root of 144 plus 324. That would be 468 equals the square root of 468. Okay, so let's see if we can, so go ahead and try and factor that. So it's divisible by 9, right? Because the digits add up to 4 plus 6 plus 8 equals 18. So it's divisible by 9. So we say, okay, divisible by 9, 52, right? 52. And then we get 4 times 13, 2 times 2. So not much you can do with that, right? Well, a little bit, right? So this is 3 times 3. So you say, well, the square root of 468 equals what? Equals the square root of 9 times 4, 36, times 13. So it equals the square root of 9 times the square root of 4 times the square root of 13. So it would equal 3 times 2, square root of 13, 6 radical 13, 36 times 13. Okay, so we put that in and we'll say, and this is 6 radical 13. Well, let's see if we can get a proportion there. So 10 to 15 is equal to this guy. Okay, so the right-hand side, call it R for right-hand side, to 6 to the square root of 13. Okay, so it's a 2/3 relationship there. So then R would be 4 to the square root of 13. And so that would be 4 to the square root of 13. Okay, so let's see if we can use that relationship in another place of these two. And that's the main one that I see now. This one looks a little sketchy, doesn't it? Oh, so this is a larger triangle. So the 12 here is just part of actually a 16, right? So this is 12, 16, and this then must be 12, 16 times 20. Okay, so this long guy is 20. Okay, so the whole thing is 20, then this guy is 15. So that makes it possible then to figure out that particular one. Okay, so let's use this to talk about exterior angles and interior angles. And so if you had an equilateral triangle, it's pretty easy to say what happens, right? Is that you have 60 and 120 3 times. So you say, okay, altogether the exterior equals 3 times 180. Okay? And if you want to know just what the exterior are, the exterior alone, exterior plus interior are 3 times 180. So exterior minus interior equals 540 minus 180. And for a square equals 360. And what happens for a square? So think about what happens for a square. And so for the square, we're looking at these angles. But again, now we have 4 times 180 is the total. So we have 4 times 180. And we subtract the interior. So the total angles minus the interior equals the exterior. So 720 minus the 360 of the square equals 360. So these 490s. And then you get your pentagon. You get your pentagon. And when you put in your pentagon, you say, okay, so this makes 3 triangles. So it's 180, 180, 180. So 540. And so each of these is 540 divided by 5 equals 108. So, oh, that's interesting, right? Is I have 540 divided by 508. So then so if this is 108, this is 72. So I have 5 times 72 equals 360. But eventually you're sort of longing for an answer in general, right? And so the total interior, okay, is what? It's 180 times 2 less than the number of sides. Okay. And the total of exterior plus interior is what? Well, however many angles you got, n times 180, right? Because every single side is going to have these supplementary angles, right? And so you say, okay, so in general, what's left is if I take 180 times n and I subtract the interior angles, 180 times n minus 2, what's left is the exterior angles. And so when I do that, I get 180n minus 180n minus 360. Okay, but it's a minus of a minus, so I have to add that. Okay, so these guys cancel out, and I get 360 equals that. And it's kind of a surprising result.